Hi, we're going to go through the extra help practice on page 17 for Learning Target 2.3.5. So looking at a real world graph and determining different characteristics, the independent variable, dependent variable, and slope and y-intercept meeting. So we're going to go through this whole page, and the reason it's a whole page is we're going to go through pretty in depth for it, so hopefully it helps. So first, we want to figure out the independent and dependent variables. And so to determine that, we want to figure out what works in this sentence. So I'm going to try it both ways first and see what makes the most sense. So I'm going to start with time as my independent. So time causes a change in the amount of air in my tank, and it isn't possible that the amount of air could cause a change in time. I think that makes sense, but let's try the other way just to make sure. So the amount of air in my tank causes a change in time, and it isn't possible that time could cause a change in the amount of air in my tank. I don't think that makes sense because that's saying, let's say my tank all of a sudden loses a bunch of air quickly. That would cause time to also change really quickly, which is not possible. So the amount of air can't change time. Time is going on at its own speed. So that means that time is my independent variable. And so I'm going to label that down here. That's my independent variable, which means this is my dependent variable. So we're going to fill in the blanks here. So we're going to say time causes a change in the amount of air, and it isn't possible that the amount of air could cause a change in time. So our independent variable is time, which is measured in minutes, and it tells us minutes. And our dependent is the amount of air in our tank measured in cubic feet. When we're looking at real world graphs, or even like when you're in biology and doing graphs, your independent variable is always going to be your x-axis. It's always going to be the horizontal one that's independent, and then dependent is on the side. So we're going to go through slope and y-intercept meeting. So first, we want to determine the slope and y-intercept without the context first. So we just want to figure out just the number values for each of those before we start labeling and explaining what it means in context with the problem. So I'm going to do my slope over here. And I could do it by choosing 2 points on the line and using my slope formula, or I can use my graph and count my rise and my run. I'm going to do it both ways to show you. So looking at my graph, let's move it. I want 2 points that are on nice corners. I want to change that. So I'm going to use this point right here that's on a nice corner. And then the next one looks to be maybe like here. I think those work. So I'm going to count my rise and I'm going to count my run, but I have to be careful because when I do my rise and I go down one box goes from 40 to 30, so I'm actually going down 10. So that was 10, and then another 10 would be 20. So I went down 10. So when I do rise over run, my run was down 20. So 10, 20, so that's negative 20. And then for my run, I'm going to go to the right, which is positive. And when I go over 1, it is just 1, 2, so that's okay. So I have 1, 2, 3. So my run is a positive 3. And so I wrote that down here. My rise was negative 20 and my run was 3 because we do have to pay attention to our scale. So let's add that in here. We want to pay attention to the scale. If I did slope by using my slope formula, I could do that. This point is 0, 40, and this point is 3, 20. And I can do my slope formula that way. So let's make sure that I counted right. I can do 20 minus 40 over 3 minus 0. And then when I figure that out, this is negative 20 over a positive 3. So they do match. So that's okay. So I can either use my slope formula or I can do rise over run. So this was my formula, or rise over run. So that was slope. And then we also need to figure out our y-intercept. So our y-intercept is where our line crosses the y-axis. So looking at our graph, looks like it crosses right here, which we actually already labeled. And our y-intercept is 0, 40. So I was able to find those without the context first. So now we're going to scoot up. For slope, we're going to put the value into a fraction and label according to the axes. And so what that means is when we have the slope of negative 20 over 3, the negative 20 was our rise, which is the up and down. So looking at our graph, that was this movement. And if it's this movement, we need that label to go with it. So when we have the negative 20, that was the amount of air. In cubic feet over 3, which was our run, and our run was horizontal, and the horizontal axis is labeled in time. So this is our time in minutes. And so we want to write a sentence basically saying this whole thing. So we're going to say for our slope, if it's negative, it's going down or it's decreasing. So we're going to say our amount of air decreases by 20 cubic feet. So that was the top of our fraction. So the amount of air decreases because it's negative, 20 cubic feet every, and then we need the time, so every 3 minutes. So every 3 minutes. And we need to make sure that we include both the top of the fraction and the bottom of the fraction in our sentence. So we did that, and now we're going to look at our y-intercept. So for our y-intercept, we want to consider how this value could be a starting point in the context. So what would that look like? So we said our y-intercept was 0, 40. 0 was the time, and then 40 is the y value, which is the amount of air. So we can say at the beginning, or we started with something along the lines, because that's where our graph begins. So we started with 40 cubic feet of air in our tank. Or we could say at the beginning, we had 40 cubic feet of air in our tank. Because if we say at time 0, we don't talk like that. We don't say like at time 0, this happened. We say like at the beginning, it was this. Or when I started, it was this. So we started with 40 cubic feet of air in our tank. I hope that helps.